Okay, Assalamualaikum warahmatullahi wabarakatuh. Look, right, before we continue with the second topic on the DC drive, let's go back to the one of the examples which is obtained from, yeah, you can refer to Sharkawi's book, page 119, if I'm not mistaken. If I can go back, page 109. Okay, we're going to look at this example, then try to understand the problems related to the force, the gravitational pull. That is very important. Okay, right. So now we start with the example 4.1. You can refer to, but I'm going to explain the solution here. So now we start with the mass. The question is the mass of the electric bus in figure 4.2. So we have a figure, the next page here. So this is a bus. So that bus has a approximately we have the weight, the mass of the bus is 5,000 kilogram, including the passengers. A single motor mounted on the front wheels drives of the bus. So there is a single motor mounted on the front wheels. The wheel diameter is 1 meter. So the wheel is diameter is pretty big, isn't it? 1 meter is very big, it's very large bus here. So the bus is normally we have a 18 inch, 16 inch for a car, isn't it? But here, for example, they put it as a 1 meter diameter. Okay, so the bus is going uphill at a speed of 50 kilometer per hour. So this bus has a speed, or we call it a V. V is the speed of the bus equals to 50 kilometer per hour. The slope of the hill is 30 degree. So there is a slope here is 30 degree, right? And the friction coefficient of the road surface are given at a given weather condition is 0.4. So we can have a mu r if you like. So this is known as a mu r. Yeah. Right. So there is a friction coefficient. What else? And then what else? We have this. Ignore the motor losses. So there is no losses. Compute the power consumed by the motor. So how to move this 5,000 kilogram bus with a speed of 50 kilometer an hour, going uphill, upward, and where the hill is about 30 degree inclination. So there is a slope of 30 hill. So the bus is climbing the hill with a 30 degree, and the friction is 0.4. Right? So let's look at the solution. So probably I can also write here. First we have 5,000 kilograms. So that could be the weight. Normally it is in terms of 5 m. So it's a 5,000 kilogram. And then we have the wheel diameter is the diameter is 1 meter. So if you can convert that into radius, so the radius is about 0.5 meter. The bus is going uphill with a speed of 50 kilometer an hour. So that could be V equals to 50 kilometer per hour. The slope of the hill is 30 degrees, so delta theta equals to 30 degree. And the friction coefficient of the road surface at a given weather condition is 0.4. So mu r equals to 0.4. Okay. So first, let's look at the condition. So we have very much. Okay, let's look at the solution first. All right, so let's look at the solution. To compute the electric power consumed by the motor, you must first calculate the total force exerted by the system on the motor. So you need to find what is the total force which is the FM, isn't it? So you need to look at the FM here. So what is the FM? Consider the system forces in figure 4.5. When the bus is moving uphill, the weight of the bus is divided into two components. So if you look at the bus again, okay, so there is a two components of the consider system. When the bus is moving uphill, the weight of the bus is divided into two components. So the weight of the bus is divided into two components, one perpendicular to the road surface, which is responsible for the friction forces Fr. So if I can write here, it's better for me to write here. So this is data here. Then we have a bus, and there's a wheel. So this bus moves speed of v here. Wait. Okay, so we have says that there's a perpendicular to the road, isn't it? Consider when the bus is the weight of the bus is divided into components, one perpendicular to the road surface. So this is the road surface, right? So there is a force which is coming down here, and there is another one which is responsible for the friction force Fr, which means this force is responsible affect the Fr. So Fr is always in that direction. Right? So the friction Fr, the force of the friction is going down there because our motor is moving uphill, isn't it? Right? Moving uphill. So we have Fr, force of the friction is going the opposite of the bus. And then we also have this Fl, right, which is one pressure, and the other, which is Fl, which pulls the bus toward the bottom of the hill. So we have another force which is down, pull the bus going down up the hill. So there are two forces here. So you need to find what is the motor force that need to apply to the motor force, and this equals to Fm equals to Fl plus Fr. So both Fm here should be equals to Fl plus Fr. So you need to find what is Fl and what is Fr. And we also know that there is a gravitational force, isn't it? And that gravitational force is always in that direction. The Fg, the gravitational force, and normally this is in terms of 9.8 meter per second squared. Yeah, meter per second, meter squared per second, meter squared per second. Just meter squared. Never mind. The unit I can't remember. So it's 9.8 something, right? So now, okay. So if you think of if you look at this trigo, the angle here, if you try to rotate it, right? So if you try to rotate that direction such that you make this perpendicular or in the direction of Ft, so you're going to have, if you move this, rotate that, and you also rotate the road here, okay, 90 degree, so you will get that angle, isn't it? Okay? So this is your ground here, and you have this as your F, isn't it? So your F, the directions, isn't it? And then you have this theta here. So this is your theta. Now you move that to that side, so that become F now. F is going down there because you rotate 90 degree, then you have that straight. Okay, so let's look at the solution again. Right. So if you move, then your FG, this is F, this is FG, isn't it? Right, and then you have this, your angle gain. So this is your F, and this is your FG, gravitational pull here. So the angle equals to that angle, isn't it? This angle equals to that particular angle. So if you look further, you can have F equals to FG cos theta. F, which is the F here, becomes FG cos theta, and you have FL equals to FG sine theta there. Yeah. So if you know, we already know what is a theta, and we also know what is FG, then you can find what is the value of F. Right. So further, and we have FG equals to mg. Okay. So this is not FG, MA. This is wrong. Okay. FG equal to, of course, M multiplied by A. A is meter per second squared, isn't it? Meter per second squared. Meter per second squared. So now it becomes G, gravitational pull, which is 9.8 meter per second squared. Right, so mg, and then you can find what is mg here. 5,000 multiplied by 9.8 meter per second squared. Okay, then you found out this is 49,000 Newton, and therefore you can find the value of the total the normal force of the bus here by this equation. Fg cos theta cos 30 degrees, so you get 42,045.25 Newton. And then we have this Fl, which is the equation. So you have Fl equals to Fg sine theta there, right? And you give that to 24,500 Newton. And the friction force, once we know what is F, then you can just multiply by the friction force, the friction coefficient. So it become Fr, and then you have this 16,974 Newton. So that gives you the value of Fr. So therefore, the total total force seen by the motor equals to Fl plus Fr, and then you have this. Now the torque seen by the motor, so you have Fm there, and therefore you can also change that to so you also have torque in that direction because you have omega m also in that direction, isn't it? So you have torque here equals to Fm multiplied by R, the radius of the wheel here. So the torque, the force that feel by made by the bus here multiplied by the radius of the wheel, so that gives you the torque that's experienced by the motor here. Right, so you know the torque is 41,474, and then you multiply by 0.5, it gives you 20,737 Newton meter. Okay, and the final part is how to calculate for the power of the motor. You just we know that power equals to, you always know that power equals to omega multiplied by T, so that should be in radian per second. Right, this should be radian per second, and this is Newton meter, but you are given in terms of V, isn't it? The solution here is not quite right, because a V given is actually 50 kilometer per hour, right? So you need to change that into meter per second, isn't it? Because omega here is 2 and we also have another equation, which is omega equals to velocity speed divided by r. So that gives you the angular velocity. So the angular velocity equals to the velocity divided by the radius of the wheel. Okay, so you need to find what's a V, but V should be in meter squared. So the solution here is not quite right, so you have to convert that into meter. So how to do that? So it's 50, you have to multiply by, this is kilometer, so you need to multiply by 1000, isn't it, to give you 50,000, and we have the hour, so you need to convert into seconds, so it's 60 multiplied by 60. Take note of that, right? So if you calculate, that will give, if I may calculate, seconds. Multiplied by 1000 divided by 60, multiplied by 60, so that gives me 13.88 velocity is meter per second. So you have 13.88 meter per second, and therefore your final power equals to, we have this equation, omega equals to V over R multiplied by T torque, so torque equals to 20,737 multiplied by V over R, so 13.88 divided by 0.5. Okay, so that gives, let's calculate, 13.89 actually. Alright, multiplied by 20,737 divided by 0.5. That gives me 576. For the 6, 0.731. Okay, so that's the answer. Okay, so that's the answer, quite different to the one in the solution, because the solution here there is a mistake, because Sharkawi should should convert that into meter per square first. This velocity should be converted into radian per second before meter per seconds. That before multiply by the top, right? So try to understand this example for 4.1, and then you can proceed with chapter 4 if you like. Okay, right? Simple. So if you look further, f cos theta divided by fg. So very much we have the angles here actually the direction. You have that, then you have 90 degrees here. This is theta. Then you have fg here. This is f, and this is fl. Okay, so that is why we get this equation fg cos theta, fg sin theta, because of this angle here. Okay, so that's example for example 4.1 from Sharkawi's book, page 109. Okay, so the FM, you need to understand that the motor force is always in the opposite direction to the load force as well as the friction force. And they are here. Right, so you have to be careful with the how to get this FL and FR and what does it relates to the other components here, the other variable that given to you. All right, okay, thank you. So that's an example.